So first step in the scientific method, make observations. Like I said in the previous lecture, you're a scientist. So you start off making observations. We're going to use the example here for this, going through the scientific method with echinacea. And, you know, to a lot of people, echinacea extract, which is an herbal supplement, seems to reduce the likelihood of catching the common cold or reduce their symptoms of the common cold, how long they have a cold. So that's the observation. There's lots and lots of different things that you can do as far as making observations. And so that's step one. Step two, formulate your hypothesis. Now, there's two different parts of a useful hypothesis. I mean, you can generate hypotheses, but a useful hypothesis must establish alternative explanations for your phenomena, whatever it is you're looking at, and must generate testable predictions. And we're going to look at predictions in the next section. But your hypothesis has to have alternative explanations and generate testable predictions. Now, generally, there are two hypotheses every time you do any sort of experiment. One is that there is what we consider the null hypothesis, and this one's just assumed, and that is there is no effect, right? So whatever it is you're doing that you think is going on, that the null hypothesis says there's no effect. And your hypothesis, which is the one that is establishing alternative explanations, aka the alternative hypothesis, is the one that we think of as the hypothesis. So that is the one right here. So echinacea reduces the likelihood of catching a cold and the duration of cold symptoms. So these are the alternative explanations for what's going on. The null would be echinacea has no effect on catching a cold or the duration of cold symptoms. Right? And this hypothesis, as we'll see, allows us to generate testable predictions. Right? So what are our testable predictions? This is where, if you've heard of a hypothesis as an if-then statement, this is where the if-then statements come in. So a real hypothesis or a true hypothesis is just it's going to do this, the alternative of no effect. But the prediction is if whatever is going on, so in this case, if echinacea reduces the likelihood of catching the common cold and the duration of the symptoms of a cold, then, and then this is where you kind of are describing a little bit of your experiment, right? Because the then is individuals that take echinacea will have lower likelihoods of catching a cold and shorter symptom or duration of cold symptoms. And then the opposite would be true of individuals that don't take echinacea. So that would be why your hypothesis needs to be able to generate predictions, right? So if you can write an if-then statement with your hypothesis, then you've got a good hypothesis, right? So the point of the prediction is to propose situations where you get a particular outcome, right? But you'll get a different outcome if your hypothesis isn't true or what we would consider actually not supported. So we've got our observation about echinacea, we've got our hypothesis, now we have a testable prediction. Now we need to design and conduct an experiment. So this makes it possible to determine whether your hypothesis is better than an alternative hypothesis. So basically whether the null, no effect, is better than your alternative hypothesis. So you're going to set up some way to be able to test your hypotheses. So here we're going to take a look at developing the hypothesis into an experiment. All right, so now we're at the experiment section. We've got our hypothesis. Echinacea reduces the likelihood of catching the common cold and duration of cold symptoms. So we're going to need a group of test subjects, right? And we're going to split them into different groups because we had our predictions about cold symptoms and catching the cold. So in this experiment, they divided them into 4 different groups, and they're going to give them echinacea at different times. So first, one group is going to get no treatment before they are exposed to the common cold, and they're actually going to do that to 2 groups because that will test the catching the cold and duration both. All right. Then they're going to give another group echinacea once a day before exposure. And then they're going to give another group a placebo. This is a sugar pill. And we'll talk about why this is a requirement in an experiment. Right, so they're going to have these groups. Then, after they've been taking their echinacea or not for a week, then they're going to be exposed to the virus. Then what they're going to do is give everybody pills. Okay? Because one of the things that people, and this is what your hypothesis is also based on, think that echinacea helps with is reducing cold symptoms. So this first pill is going to help you keep from catching it, right? Because that's before exposure. So this group right here should, if echinacea does help, should have a reduced amount of infection. And then the other part is the duration. And so the second part, they're going to take the pills after they're exposed. So if they do get the cold, these pills should help reduce their symptoms and reduce the duration of their symptoms, how long they're sick, if they do have echinacea. So in each one, you still have one with a placebo, one with a sugar pill, one with echinacea. And then for the group that had no treatment to start with, same thing, one with echinacea, one with their sugar pill. And then for 5 days, the doctors will monitor all groups for their cold symptoms. So that is what they're going to do. So the treatment, oh, look at that. I just described all of it. So the treatment, they divided them into 4 groups. 2 groups took that pill daily, 1 group with the placebo before exposure, and then the 2 groups took a pill daily, with 1 group getting that placebo after exposure every time. So then after the experiment's done, then it's time to start drawing our conclusions, which means taking the data, looking for patterns and relationships in that evidence, in that data, seeing what happened. Determine if findings and conclusions, so did your data support the hypothesis? So are any parts of your hypothesis, if it's like this one, if there's more than one part, any part of your data support any part of your hypothesis? And if the result is not what you expected, it doesn't make it a wrong answer. It just means that you need to adjust your hypothesis and probably conduct additional experiments. So that's one of the things that people often think of with science, that we just stop. But the thing is that a lot of times what we do is redesign an experiment. You look at, oh wow, that's not what we thought was going to happen, and take that data and say, okay, so this isn't what we expected, but here's what happened, and now what we can do is take that information and go in this direction with it and see what happens. And so we continually are changing these hypotheses, changing these experiments as we get new information, because basically this right here is a new set of observations, and so it can set off a whole new set of experiments. So let's see what happened with the echinacea experiment, because this is a real experiment. So here is the data. So group 1, before and after exposure, so they got echinacea both. Did they get cold symptoms? Yes. So they caught the common cold, and they had symptoms for 3 days. The group that had the placebo, the sugar pill, before and after, same thing. Echinacea after the exposure, same. Placebo after, for these are the no treatment groups, before, same. So the thing is in this experiment, they found that all the groups were equally likely to develop a cold with symptoms lasting 3 days. So this experiment does not support that echinacea prevents the common cold or reduces the duration of the cold symptoms. However, that doesn't mean that echinacea just gets thrown out the window, because you can continue to run the experiment and change the experiment. Alter the amount of echinacea. Maybe you weren't giving them enough to actually get the effect. Or alter the length of time that they get the echinacea. Maybe you weren't giving it to them for a long enough period of time for their body to be able to use it. So if you were only giving it to them a week, give it to them for 2 weeks before their exposure. You know, if you were giving them 1 pill, give them 2 pills to alter the amount. So, you know, the initial hypothesis was not supported, but there are opportunities for new experiments.